All right. So let's talk about this a little bit. Kristen Gilbert started working at the VAMC, is the Veterans Affairs Medical Center. So she was working at a hospital that serves veterans. Highly skillful, calm, compassionate. She got this nickname. She was the Angel of Death because she had this knack of being around when there was medical emergencies. I, on purpose, left this last piece out right here, this last little bit that's a blank line. According to a search warrant affidavit, a statistical analysis of codes and deaths in Ward C between January 1st, 1995 and February 19th, 1996, so a little bit more than a year, showed that Gilbert was present or on duty for 37 of them. Authorities determined the likelihood that her frequent presence during these emergencies was merely coincidental was blank. What other explanations might there be for why Gilbert had more deaths on her shifts? Maybe the patients were in worse condition. Any other thoughts about why she might have been around? Does anybody have any thoughts? Yeah.
She's like skilled, so they had to bring her in like when it was like serious.
Absolutely. It is describing her as highly skilled, so maybe this is one of those, like, if she's anywhere in the building on the shift and they have an emergency like this, they're calling her in. Or making sure to schedule her when they know ahead of time that they're going to have difficult cases, something like that. Absolutely. Something that got brought up in years past as a possibility is, did she have a habit of working more nights than days? Because just statistically, we know that there tend to be more medical emergencies and deaths at night versus a day shift. So maybe she just worked nights, and that's the explanation for it. There's certainly, just going off of the little bit of the article that I gave you guys, the summary there, would you say that she is hurting people? Not necessarily. Is there some evidence? Our question, though, is whether or not it's convincing evidence. So what statistical information, what more would you want or need to know if I was going to ask you to make a decision about whether these deaths were coincidental, purely by chance, or did she have a hand in it? What more would you want or need to know? One more time. The probability of it occurring by chance, absolutely. How would we go about determining the probability of this happening purely by chance? What more information would you need if I was going to ask you? Because that's what we've spent time doing with all of these different statistical tests that we've learned how to do, is we've figured out what's the probability that this occurrence happened purely by chance. So what more information would you need if I was going to ask you, okay, run a statistical test and tell me whether or not you think she did it? Knowing the average death rate would be helpful for the facility in general, for the floor that she's on, for the shifts that she works. Do you think that's an easy number to get your hands on? Maybe for the whole facility, but it might be a little bit stickier if you're looking like per floor. I don't know exactly how the hospital keeps track of all of those different kinds of records. What have we done to obtain evidence in here? We've sampled. If we had a random sample, could we use that to run a statistical test? What would you want it to be a sample of? All nurses. We would want this to be a sample of all nurses, specifically at this hospital though, right? So instead of narrowing it down by nurse, what they did is they looked at all the different shifts, just like any given hour, if there's 5 nurses on the floor, that would be 5 different shifts because each of them is working a shift. So if you guys flip the page over, I have that. 1,641 8-hour shifts were randomly sampled from the hospital's records. I want you to use the data in this two-way table to determine the probability that her being around when these deaths occurred was purely by chance. What kind of a test would you want to run? Absolutely. We'd be running a chi-square test for independence. We want to know whether her working these shifts and the deaths happening are unrelated, they're independent, or is there an association here? Is there a relationship? So chi-square test for independence is what I want you to run. Take about 5 minutes. If we need more time than that, we can have it, but let's see if we can do this test in 5 minutes. We are almost at the 5-minute mark. Who needs a little bit more time? Okay, we'll do another couple of minutes. I'll check back in with you in about 2 or 3 minutes. Row times column, row total times column total divided by grand total. So like for this expected count, we do 257 times 74 divided by the 1640. Row total times column total divided by grand total. So for yes, yes, to find that expected count, we would do 257 times 74 divided by 1641. And that would be your expected for up here, which it's fine if you just write the expected counts next to these. That would be fine.
So you say row total times column total divided by grand total.
Mm-hmm. I'm sorry. For all practical purposes, that's what it is. I'm just curious why it didn't give it back in scientific notation. So I'm going to lean towards, no, you didn't do anything wrong, and this thing just decided to round it off. That would be my best guess. Or you can put the squigglies for about. You guys ready to talk about this? All right. Who has gotten through the calculate step? All right, so we're going to go through this line by line, but I want to know from those of you that have finished the calculate step, do you think she's guilty? Let's walk through it a piece at a time. All right, so we're going to do a chi-square test for independence. Alpha level. Normally we go with what? Normally we go with 0.05, right? I want you to think about this situation though, because this significance level is kind of determining the probability that we make a type 1 error, right? What's a type 1 error again? We reject a true null. What would the null hypothesis be here? There is no association between Gilbert's presence and death during shift. So if we make a type 1 error here, then we are going to reject that, which would mean that she really didn't do it. There's no association. There's no relationship between her working and people dying. Do you want to take a 5% chance on that? If we're thinking about accusing somebody of murder or multiple murders, I want my chance of rejecting a true null to be as small as possible. So I went with 1% on this. If you wrote down 0.05, I understand, because we've talked about when in doubt, when they don't say, put 0.05. But I went with 0.01 because we're playing with somebody's life here. Like, this is a real situation. So the ho is that there's no association between Gilbert's presence and death during shift. So what's the ha? That there is an association. That there's some kind of relationship between her working and people dying. For random, we just kind of have to assume that those 8-hour shifts were randomly selected. 10%, do you think it's fair to say that there's more than 16,000 some odd 8-hour shifts at this hospital? Yeah. Large counts, so you need to do your table. I did my expected counts. I got 11.59 for yes, yes. 245.41 for Gilbert present but no deaths. 62.41 for yes, death, but Gilbert wasn't working, and 1321.59 for Gilbert was not working and no deaths. So we get our large counts. All of the expected values are more than 5. Then we go to calculate. Observed minus expected squared divided by expected. We're going to do that for all of our observed and expected pairs. So I know I told you guys that unless we're doing goodness of fit, the calculator does not run this test. There's kind of a hack that you can use for this, though. When we're doing goodness of fit, we're taking one set of observed values and comparing it to a claimed distribution. So we have just like one row or one column, right, with lots of rows in it. If you're careful and you make sure to match up your observed and expecteds in a table, you can run a goodness of fit test on the calculator to get your components and to get your test statistic and your p-value. Do you guys want to see what I'm talking about? Okay. What I would do, I'd go to Stat, Edit, clear anything out that's in your lists, And now you're going to have to decide, are you going from the top of the first column down and then starting on the next column? Or are you going to do across the row and then go to the next row? All right? You have to decide what you're doing, because it would then have to be the same for your expected. Whatever you do for your observed, you have to do for your expected. All right, so I've got the 40 deaths when Gilbert was present, and then I'm going to do the 34 deaths when she wasn't present, and then 217 shifts with no deaths when she was present, and the 1350 no deaths but she wasn't working. So I'm putting my observed in there. I'm putting it just in one list. It's in a table here. There is a way using a matrix to get the calculator to do this. I'm not super familiar with matrices on the graphing calculator. That's why I'm not showing it that way, because I'm just not comfortable enough with that particular feature. If you know how to work the matrices on the calculator, I can show you what to do with your matrix. All right, then over here, we're going to put our expected, and I have to make sure to match up my observed with my expected. So 11.59 for expected yes, yes. 62.41 for death, but Gilbert was not working. That's our expected. And then 245.41, 1321.59. And then I'm going to run a goodness of fit test. Even though I know this is not a goodness of fit, it's going to go through, it's going to do that subtraction and squaring and dividing by the expected. So I have my observed and my expected. How many degrees of freedom? 1 degree of freedom. Number of rows minus 1 times number of columns minus 1. We had 2 rows and 2 columns, so I have 1 times 1, which gives me 1 degree of freedom. And I come down here to calculate. One of the components is 69.64. That one corresponds to what? Deaths during the shift when Gilbert is present. So when Gilbert's working, deaths during shift. This is the component that goes with that. And then we have our next component, which is 12.93. Then we have 3.29 and 0.61 to get our components. But the component that jumps out the most to me is that very first component, the 69.64. When you add up all 4 of those components, you get a chi-square test statistic of 86.47. If you got something around there but slightly different because you rounded differently, that would be fine. And a p-value of 1.41 times 10 to the negative 20th. For all practical purposes, that's what? For all practical purposes. Don't forget to get your picture going on here. Chi-square, 1 degree of freedom. And so then we conclude. What is this 1.42 times 10 to the negative 20th? That's our p-value, and the p-value is, this is the probability of having those observed counts purely by chance, if there's no association between these two things. So you remember at the beginning where I asked, you know, they determined that this happened coincidentally, this happened purely by chance. That's what we just calculated. Assuming the HO is true, there's no association. There's a 1.42 times 10 to the negative 20th probability of getting a chi-square value of 86.47 or more purely by chance. And so we reject or fail to reject? Reject. We have convincing evidence of an association between Gilbert's presence and death during a shift. And then my follow-up analysis. The largest component of chi-square is 69.64 because a death occurring during a shift Gilbert was working was far higher than expected. Which means what? Probably guilty. Now, would this be enough by itself to convict? No. Would it sway you if there was more evidence, if you were on the jury? Absolutely. So I would say yes. The p-value is so small, it's very unlikely to get these results purely by chance. So there was more evidence presented in the case. She was convicted. She did go to jail. To add a little bit more, without having to read all of the news articles, if you guys are interested, I can post them on Canvas. You can read through them if you want to. She was having an affair with a police officer that was assigned to the hospital. And she had also been stealing epinephrine from the medicine cabinet. And so obviously some of this you can't prove what someone's thinking. You can only show what they did. But the theory put forth by the prosecution that was convincing enough to the jury was that she loved to be the center of attention, especially when the guy that she was having an affair with was there. Because then she would be the rock star that saved the day, that saved this person's life. So she was injecting them with epinephrine, which would make their heart rate and it would make them code. And then because she knew what had caused it, she could come in and try to fix it. She couldn't always fix it. And so ended up killing these people. So yeah. Are you finished or do you need to work some more tomorrow? Did as much as you could. Okay, sounds good. Kind of interesting. They did use a chi-square test for independence in this case. So it's kind of cool that what we're learning now actually has some real world applications. I had a couple FRQs on deck, but I think we'll look at those tomorrow. Something that I did want to show you guys, though, that is posted in Canvas. If you go to today's page and you scroll down here to task number 5, which test to use, this is really helpful, not just for this test coming up, but gearing up for the AP Stats exam in May. I know the background color leaves a lot to be desired and the text is very small. But you can go in here and tell it, like, I'm having trouble picking out the difference between these 3 tests. So I'm going to put chi-square goodness of fit, chi-square test for independence, chi-square test for homogeneity. It's not liking my touch screen right now, but with the mouse you can click on those. And then you click submit. Yeah, it's just really not liking my touch screen. You click submit and it will put up a scenario and then ask you which test. And just back to back to back to back to back so you can practice with those over and over and over and get a bit of a better feel for when do you use chi-square test for independence, when do you use it for homogeneity, when do you do it for goodness of fit. Do you guys have any questions for me? An FRQ day, but still kind of an FRQ.